Hello all. This session will deal with the introduction of random variables. So first let us define the term what is meant by random variable. Random variable, normally abbreviated as RV, is going to be a real valued function defined on the sample space S, and for each element small s that is going to belong to your capital S, we associate a real number, and this association is carried out by this real valued function. So basically, a random variable which is denoted by say x takes the element of the sample space to real number system. Hence we say that this takes every element S over here and then associates with a real number, in which case we write x of S is equal to the real number x. Here your small s belongs to the sample space and the small x belongs to the set of real numbers. X is a variable. X is a variable. What do we mean by variable? It takes different values at different point of time. Then you call it to be variable. Next, the term random. What does this mean? Randomness means it keeps on changing depending on a certain probability. So at different point of time, if it takes the different values with different probabilities, then that variable is called as random variable. So it is a real valued function defined on the sample space and associated to a real number. Next, we will see the definition of range space. What do we mean by range space? Denoted by the script R suffix x, range space of the random variable x. This denotes the set of all values taken by a random variable x and is denoted by Rx. Say suppose we are considering the example of tossing two coins. So what will be my sample space consisting of? It consists of head head, head tail, tail head or tail tail. Now for each of these outputs or the elements in your capital S, if I am able to associate a number, so what can that be? Let x denote the number of heads say. So what does x, the random variable, now stand for? The number of heads. Now what do we do? The range space will be the number of heads. So in the first case, how many heads are present? You have 2 heads. In the second case, how many head is present? You have only 1 head. In the third case, how many heads are present? You have 1 head. And in the fourth case, do you have any heads? No, we don't find any heads. So the number of heads taken is going to be 0. So I say that the number of heads taken can either be 0 or it can be 1 or it can be 2. So my random variable x can take the value 0, 1, 2. Hence, my range space R of x is the collection of all these numbers. So it will be 0, 1, 2. So this is how we define the range space. Now coming to the types of random variable. So how can we classify this random variable as? Under broad classification, this random variable can be classified as discrete random variable, so we can abbreviate it as RV, and continuous random variable. Okay, so these are the two broad classification of a random variable: a discrete random variable and continuous random variable. So what is meant by a discrete random variable? A discrete random variable is one which takes finite or countably finite number of values. It is going to be finite or it takes countably infinite number of values. So if your range space Rx consists of finite number of values or countably infinite number of values, then you call the random variable to be a discrete random variable. And now what about a continuous random variable? So if your range space is going to be a collection of infinite number of values. So in this case, your range space contains infinite number of values. So when does it contain an infinite number of values? When you are specifying the random variable in a range. Say suppose in the interval a comma b. In the interval a comma b. Then you call the random variable to be a continuous random variable. So can we have an example for a discrete random variable? So how things can be counted? So like the number of hits when two coins are tossed. Then what happens? You will have either the random variable to take the value 0, 1, 2. So in which case it is finite in nature, and you call this random variable x to be a discrete random variable. And how about an example for a continuous random variable? The lifetime of an equipment. So it says the lifetime is going to be between 0 to, say on an average it lives for 5 years. So the random variable will now take the value 0 less than or equal to x less than or equal to 5. So in which case I cannot just pinpoint out like 1, 2, 3, 4 and so on. How many numbers are there between 0 to 5? You have infinite number of values in your interval. So whenever I am defining the random variable in an interval or a range, then it is defined as a continuous random variable. Now, to measure the probabilities of a discrete random variable and a continuous random variable, we define two concepts called as probability mass function, and for the continuous case we define a probability density function. So this is abbreviated as a PMF and this is abbreviated as a PDF. So we will see what is the difference between a PDF and a PMF. So as we saw, a PMF, the probability mass function is associated with a discrete random variable. And say suppose if we have our capital X is the random variable that takes the values say x1, x2, x3 and so on in such a way that probability of x is equal to the value xi is going to be p of xi. Then this p of xi, the probability has to satisfy two conditions. The first condition is that the individual probabilities over here associated with each of these random variables must be greater than or equal to 0. And this must be true for all the values of I which varies as 1, 2, 3. So individually if x1 is associated with p1, x2 is associated with p2, x3 is associated with p3 and xi is associated with pi. Each of these p1, p2, p3 must be greater than or equal to 0. The second condition is that when we add all the probabilities, the total probabilities p of xi, the radiations over I must be equal to 1. We know that the range of probability is always between 0 to 1. When the probability takes the value 0, it is going to be termed as an impossible event. So when we know for sure that that is never going to happen, then we have the probability as 0. And the probability is always 1 for a sure event. What do you mean by a sure event? For 100% I am accuracy, I am saying that this will happen. Then the probability will always be 1. When we add the total probabilities of all the data, the total probability must be equal to 1. So if these two criteria are satisfied by these probabilities, then you call it to be a probability mass function. So a probability mass function is one that satisfies p of xi greater than or equal to 0 and summation p of xi is equal to 1. Now coming to the second part, which is the probability density function, which is your PDF. And this PDF is defined for a continuous random variable. So if capital X is going to be a continuous random variable and you have a function called as f of x defined, then this function f of x is going to be called as the probability density function if this is going to satisfy two conditions. Now again in a similar pattern to over here. The first condition is that the function f of x must be greater than or equal to 0 for all the values that x takes between minus infinity to plus infinity. Why we have defined this range? This is because we know that the random variable takes all the elements of the sample space to the real number system. Okay, so your x belongs to the real number system. Okay, so this is going to be varying between minus infinity to plus infinity. And the second criteria for this will be similar to this. When you add all the probability, the total probability must be equal to 1. So when you integrate all the values between minus infinity to infinity, then the value for your f of x dx must be equal to 1. Or in other words, you can say that integral over your range space x f of x dx is equal to 1. Now the main observation over here, when it comes to a discrete random variable, so what is the operation which we are using over here? The operation which we use over here is going to be your summation. The operator which we are going to make use of for the discrete random variable will be summation. You add all the data. But when it comes to a continuous random variable, there are going to be infinite number of values, so you cannot literally add them one after the other. So the mathematical operator which will be involved over here will be integration. As we saw, for a discrete random variable, summation of all the probabilities must be equal to 1, And for a continuous random variable, integration of f of x dx must be equal to 1 for the range space x, and this is for the range space I.